Okay, so last week we talked about difference between two proportions, population proportions. This week we're talking about difference between two population means. I'm hopeful we can get through the notes together today, all the way through today, and that you guys can have plenty of work time on the Excel lab for the second half of the week. Also, at this point, after today, you should be able to start working through the Unit 9 homework. We'll see. It's not. Normally I try to split up notes and not do them all on a block day, but we have an interesting schedule this week. So, all right. So, first of all, before we can really talk about inferences between two means, we kind of have a new thing to think through that is true of means that isn't really possible with proportions, okay? And that is that we can have two samples that are either independent or dependent, okay? So independent samples, those come from two distinct groups. Or two distinct populations. With nothing tying a individual from in one population to an individual in the other population.
So does that just mean like no relation from each one?
Correct.
Lots of populations.
Two.
I'm just saying I'm sure there are 3.
Okay. Whereas dependent samples, there's two different versions of dependent samples. And dependent samples, you can directly compare individual observations. Okay. For example, and there's two kinds. We have paired and we have matched. Okay. And paired data, and examples of a paired dependent sample might be a before-after study. Right? Where I made you guys do something before and then made you guys, like, say, take a pre-test, make you take a post-test, right? Then it would make sense to directly compare each individual's pre-test and post-test. And so paired usually is the same participant. Okay. Match data is linked, but not same participant, essentially. So, for example, if we wanted to compare the heights of children to their parents, there's something that links them, right? But they're not the same person. Twin studies would be an example. And whether or not something is an independent sample versus a dependent sample influences how we do the test of significance or how we do our confidence interval. Okay? So, let's look at this one first. And what kind of samples are these ones? Independent or dependent?
Yeah.
Independent. Because there's nothing that ties an individual in the caffeine group to an individual in the placebo group. Everybody good? Okay. So when we do independent samples, our hypotheses are going to be about both means. So, let's see. What do we have here? I'm going to do mu C equal, let's see. What are we trying to show? Has no effect.
Yeah, so that would be.
So that would be mu C equals mu P and mu C not equal to
What's the P? Sorry.
placebo.
Let's see about that.
Okay. And let's see, what all do we know here? We have
49.
that NC equals 49, NP equals 31. Yes? Huh? What else do we have? Alpha equals 5%. What else do we have? X bar C is
4.8 minutes. Right? Yeah.
and X bar P is 5.6,
6.
and that the standard deviation for both groups is 1.1, yes? And that is a population standard deviation, yes? Which tells us this will be what kind of test? Will we be using Z or T? Z. Because if we know the population standard deviation.
Oh, never mind.
But you put standard deviation of C for both of them.
Yeah.
Oh, yeah. Well, it's because it's both of them.
So 2 samples equals.
Can we just write standard deviation equals 1.1, or do you have to write it separate?
I like seeing both, but it does, I mean, theoretically it doesn't matter, but I might give you two separate ones. I think it's good habit. Okay. And all right. So, what do you think we should pick in our calculator? 2 sample Z test. What are we getting?
Negative 3.161.
Okay, and the p-value?
0.002.
Are we all in agreement here? That's probably something at.
Wait, I put, I said 169.
Oh. Sorry, I heard 161.
Sorry.
No worries. As long as we're all on the same page. Everybody good?
Yep.
All right. So now what? That's less than our alpha, right? So we reject the null. All right. All right. We have enough evidence. to reject the claim that caffeine has no effect on attention span. Now, that being said, you guys, do you think they're actually going to start giving kindergartners caffeine?
I think they should.
They say it stunts your growth.
Not.
Okay, I've been drinking coffee since like 5th grade though, and I'm not sure, so.
So
I-
maybe
I-
you
I-
could.
But you don't know, but you don't, like,
Is it just physical growth?
But yeah. That was onto something.
I agree.
I know, no, don't even.
I don't think you understand
I
that.
don't think you already.
That was messed up, but I'll just take
No,
it.
I'm just saying.
I'll just take it out. No, it's cool. It's cool.
Are we good?
Wow.
Yes.
Yeah.
The little ones?
It was like a
Poorer
poor performance.
performance. You're right. It's worth noting that in this confidence interval here, the whole interval would have been negative. So like that interval can kind of tell us a little bit more if we look deeply in it. Okay.
What's that? I thought you were supposed to.
All right.
Oh. I thought you said two.
Same idea, except for now,
Oh, yeah, I'm on. I saw that.
it's on you guys instead of on kindergartners, yeah? This seems like a fun one to make you guys do on your own. Your last test was just approved, y'all. And he said he'll have the final to me by the end of the week.
Oh.
When is our next test?
I don't know. The block day, so for you guys it'll be April 30th.
Oh.
So we still got like a
We
week or
do
two.
9, 10,
Like,
11 this evening.
alright, we're chilling.
Do you know how many questions the fourth test?
5 contexts.
So like,
So this might be one question, but there's a part A, this might be one question.
But you split it up into like, what is all the information, what are the hypotheses?
heck yeah. Alright, so.
Just like the last test was set up that way, right? Where I gave you some scaffolded questions to, I can't remember. I think there's some confidence in. Okay. All right.
How many questions did you say?
5. I think it was 5.
Okay. I mean, I'll take it.
5. Most of them have 4 or 5 parts. Okay.
we? I have a question.
Mm-hmm.
Like, all right. Hold on. I don't want to ask it just yet. No, I'll ask it. How do we know that we're using the two z-test versus the t-test? Because where's the proportion?
Z-tests are always used for proportions. That's not the only time you use a z-test. You can use a z-test for means if you know the standard deviation of the populations.
Oh yeah. So because we know the same.
Because we know the sigmas,
Okay.
we use a
that's why.
z-test.
Okay.
Yep. If you wanted to test kind of what you got from your calculator so far.
Oh, I didn't see -10.
Your p-value always needs to be less than 1 because it's a probability.
Got it.
All right, you guys, so therefore we are going to, that is less than 5%, I think, because it's pretty much 0. So we'll reject. Everybody good? Okay, and so in this case, again, the claim is that the caffeine has no effect. We're rejecting that claim. Now, you guys, just as a quick reminder, because I think I actually do this on the test. If we did a confidence interval, what would we expect to see here? Would 0 be in the interval or not? Are we saying it's possible that that the difference between the two groups is 0? No, we rejected the idea that they're the same, right? So that's you guys, let's go ahead and just for fun, go and see that 2 sample t interval. You got to go down a little bit. I'm sure it's option 0. And
It's not.
What do you say? Go to what?
2 sample z interval. Oh, I chose the wrong one. This is a z interval. Yeah. 2 sample z interval is 9. Okay, and what confidence level should we use in this particular case to make the same conclusion? If alpha is equal to,
0.95.
this case would be 0.95. Two-tailed, alpha's 5%, would be 2.5 in each tail.
So maybe 0.97. 0.975 to 1.82. Yeah, 1.82.
That's so weird. What's that?
That's all the same. That's
Oh, okay.
Like one question.
yeah, just fill out the rest of that information.
Okay. Oh, because alpha.
You said you're gonna ask that on the test.
You're going to be asked to do confidence intervals as well as tests on the test.
And it's always just taking the like difference. So
Oh, okay.
0.05 and 2.95. Or it's like
Always is a tough.
okay.
If my initial test is one-sided, That would be different.
But we could have expected that 0 wasn't gonna be in it because we rejected HF.
Correct.
and the null
Correct.
hypothesis. Okay.
Also, there's another huge distinction between this one and the first one. Did the caffeine help the seniors in this particular data set?
Yeah.
Mm-hmm.
The caffeine helped?
Wait, how do we know?
That's a worthy discussion.
It had an effect.
It did have an effect. Was it a positive effect?
I think it was like a longer attention span, right? I mean, hold up.
Yeah.
Yeah, longer attention span.
Okay. And interval, I can see that this interval is positive.
Yeah.
Had we done
This is t-test?
And which one are we going to use? We're going to use a 2-sample t-test instead of a 1-sample t-test. Again, so this is still only, these are applying to independent samples. We're going to get through the independent samples first. We'll take a break, then we'll do dependent samples. No falling asleep in my class today.
Graham, you clicked your binder right when that happened. I know.
They just read the track. They read
I don't know, but you gave me this answer. Okay? Equals 2, so we'll probably have to talk through that. Okay?
But what about this?
What if we don't know the population stand?
So wait, what are they doing?
We're focusing on this. All right. Now, you guys, when you go to do a 2-sample t-test, your calculator is going to ask you something about pooling your data. The decision on whether or not you should pool your data is outside the scope of this class. So I'm not going to go into the details of when should you say pooled or unpooled. For this class, you will always unpool. Okay? There's reason that sometimes what they mean by pooling your data is creating one giant sample. Okay? We're not doing that. Everybody good? All right. Okay. You guys, are these independent or dependent samples? Independent. We're talking about 2 populations, the U.S. call center and the overseas call center.
And whatever, yeah, independent.
And yeah, but you're going to need to be able to make that distinction on the test. Like, I don't tell you which one, right?
Is that gonna be a question? Like whether it's independent or dependent?
I mean, I don't need to ask the question the way you, like, if you pick the wrong procedure to do, if you put the, like, tells you which one you're putting in the calculator.
Got it, alright.
But when you choose to read it, because you wouldn't have enough information, you would have information you don't have.
Not necessarily.
Dang it.
All right.
So that's why we did the test me this last time. You'd know if you're doing the wrong one because you didn't or did have information.
Correct. All right. Guys, what are my hypotheses here?
It's gonna be U
We can just use U and
and O.
O for overseas. That's fine. Call times are lower in the U.S., so U is less than mu O. What does that make my null hypothesis? Okay.
How would you figure out the confidence?
So let's sketch a picture of what the test would look like.
Oh, so you put 0.025 points.
Not for a one-sided test. So this is what the picture would look like. So if I'm doing a confidence level, I want this chunk. So it would be 90%. Would equate to that alpha.
Wait, can you repeat that?
Sure. If I just do the test, my alpha is 5%. It's a left tail test. The picture looks like this. Confidence intervals, like your confidence level is the middle chunk. Yeah? So for it to be a middle chunk, you would need a 0.05 on the other side for it to make that because this is your critical value no matter what. So if this is 0.05 and this is 0.05, your middle chunk would be 90. So for the test, we're going to do left-tailed. But if we were to run the confidence interval, it would be a 90% confidence interval, not a 95% confidence interval.
So if it was two-tailed, it would be
95%. Yeah. If it was a if the test from the get-go was was two-sided, then that 5% would be describing the total of both tails. But since the test is one-sided, that 5% is only describing one tail. Confidence intervals are always two-tailed, so you would have that other 5%.
So there's always the middle chunk, but if it's one side, you just keep it the same, and if it's two sides.
Other way
you
around.
split it in half.
Yeah. We were talking. The it you said was a different it than what I was thinking.
So when it's equal to, is when it's going to be two-sided.
Yeah, when the alternative is not equal to, so it could be greater than or less than.
And it's two-sided, but if it's not,
Okay,
I know we're not doing that, sorry.
it's all right. So this time you would need to choose a 2-sample t-test.
How do you do
Oh, between the standard.
Because this time the standard deviations I have are of the samples. And that you know this because you want to know how I know this. And then we should throw it in. Again, when it asks you to pool, you're always choosing no. Then I will not give you any questions whether you should have pooled.
So T is negative 1.35. And then P is 0.09. Yeah. Which is we failed to.
Oh, I did the wrong one. Yes, for my interval, because I accidentally picked the wrong one.
Come on.
Well, I was going to make you run the interval, and I ran the interval for you, so whatever.
It's fine.
The 290.
Yeah. Well, it was 289 something.
Oh, wait, I didn't know that.
Yeah, neither did I.
For the two-sample t-test.
Correct. I got t equals negative 1.69
Oh, wait.
and 0.
I got what Beck got.
Yeah.
I'm talking about your interval. For my interval, I got negative 3.569 and 0.3693.
X bar is 18.2, standard deviation is 6.1, n equals 50. 19.8. Oh. I did 2.5 instead of 5.2. Okay. So that means this is wrong too. Okay.
He's working, Joe.
Yeah, thanks. Party,
He's behind me. Good job.
Did you get 3.569 to 0.369?
Yeah.
That's what I got. Okay. All right, guys. Conclusion?
We failed to reject because
It's greater than alpha.
yeah.
So we failed to reject. Okay? We do not have sufficient evidence to suggest call times are lower. Again, I'm just using the verbiage from the question.
Can you also say
So I,
because of the interval having
Yeah, so the interval containing 0 also suggests that.
Are we ever gonna need to use like these? Or are those just there for
The-
like moral support?
I mean, those are
Calculator, right?
like those are the formulas to find the z statistic or t statistic.
Okay.
But to be honest, to calculate your p-value and stuff, so you'll notice as we do these, before we had something called degrees of freedom, right? Like when we had that t statistic, we used degrees of freedom. It was always our sample size minus 1. This example is a really good example of like how do you decide what your degrees of freedom are. You guys, one of our sample sizes is 50 and the other one's 41. So which sample size do we use? And the answer is there's a whole lot of weirdness that goes into that. There's a super fancy formula that your calculator already uses. So like for instance, I'm looking at mine and the degrees of freedom was 88.85. Okay, because it's a fancy formula. So because I'm not going to make you guys do that fancy formula, you're not going to necessarily find those test statistics by hand. You're just going to let the calculator give them to you. It's fine. Okay. Because without the degrees of freedom, test statistic is silly anyway. And when the degrees of freedom isn't a nice, easy, just your sample size minus 1, it's more complicated because you have 2 sample sizes. We'll just kind of use the calculator instead. Okay. This seems like a really good place to take a breather. Let's come back at 45. It's a 5-minute break. Do this one.
We're not doing the bottom one.
The bottom one, if you look, is identical to the one we just did.
Oh,
I obviously,
the more you know.
I'm not going to make you do the same problem twice. That seems ridiculous.
Oh, I'm so tired.
So faster suggests that the time of one is lower because something is faster when it takes less time.
Thank you. God, dude. Oh.
Do my hypotheses make sense?
Hmm?
Do my hypotheses make sense? The first one is like the franchise on the weekend.
Well, like you're comparing weekend to during the week.
Yeah, I just did F.
So F is during the week.
Mm-hmm. And weekend.
F is during the weekend.
Mm-hmm.
Then yeah.
Okay.
Which one's which on yours?
Mario.
So, try Mario calculator. Oh, that, right.
This is one where again, if you wrote a little note as to what stands for what, you could have used A and B, 1 and 2. It doesn't matter as long as you know which one's which. It's fine.
Can you explain, after we're like done, can you explain how you did the hypotheses? Because I know it's a little different.
It just the question is, are they faster? If something is faster, it takes less time. So the mu here is the time it takes.
Oh, okay. Alright.
Would it, would the confidence interval be 0.95 or
The-
0.9?
0.9. So picture-wise, my alpha is here. Confidence interval, you would need that kind of ghost side of 0.05 as well, leaving 90% in the middle.
I don't understand. So if it's a one-level test,
Do we need to do confidence interval? I'm confused.
If I didn't ask for one, but he asked, so I said,
so if it's originally a one-tailed test, then we duplicate the alpha.
yeah.
Okay. And then if it's originally a two-tailed, we duplicate the alpha by 2.
Because it's already two-tailed.
It's cool.
Thank you. I know I'm writing these in weird orders in terms of.
Oh, sorry.
Yes. How'd I do?
Silly character.
Do you guys sound alike?
Yeah.
You guys do sound alike. I guess I never put two and two together.
My mom thinks
When I hear myself on like one of these recordings or something, it creeps me out of how much I sound like Katie, my twin.
I don't think you sound like Ellie at all, Matt.
Okay. I think so.
I think in some instances.
Oh, Matt, the golf cart won't turn on again.
It won't turn on.
Won't turn on. Is that what happened? We took Ryan, Kate, and Ellie and Matt to the pool, the Grand Air pool yesterday, and we had to push it up the hill. We went 2 miles an hour all the way home.
We feeling okay about this example, y'all? Okay. So, let's look at this next one. All right. You guys, what about this? What can we say about these ones?
Dependent.
They are definitely dependent.
That
Are they paired or matched?
they are paired.
Paired. Okay? Because they come from each of these is the exact same person. Okay. All right. So, here's what happens when we have a paired thing. Okay? Am I allowed to directly compare this 22.3 to this 21.9? Yeah, because it was the same person, right? And when we make that direct comparison, essentially we're trying to look at, is there a difference or not? So we're going to do the difference. So like for this person, I would do 22.3 minus 21.9, which is 0.4. Everybody good?
Yes.
You get the basic premise of what we're doing. Okay. Now, does that mean you have to type these in for 7 different people? No. So let me show you some lovely calculator stuff we got going on here. Okay. So what I'd like you guys to do is put the standard times in your L1 and the times with cooling in your L2, please.
It was my sister and me.
That's loud.
No one has ever said that besides my mom.
First time for everything.
Yes.
Now, it is important, because these are paired, that they line up next to each other. Everybody got them in? Okay. And what we need to do is find the difference for each of these. Are you with me that essentially what we want to do is do all the values in L1 minus all the values in L2? So if you guys go over to L3 and go up to the top and hit enter. So what you have, so what you can see at the bottom is specifically only L3 equals. Is everybody with me?
Yes.
All right. then you can tell it to do L1 minus L2 by hitting second 1 to bring up the L1. Minus L2, doing second 2. And if you hit enter, it'll fill all of those in. It'll give you all those differences. Is everybody good?
Yep.
And just for kicks, I'm going to write these differences down, but the bigger piece is just let's all remember that L3 is all of the differences. And we got, oh man. Negative 0.1, 0.3, 0, 0.1, 0.3, and 0. And guys, on your, just by looking at these numbers, do you think that the ice bath helps?
Yes. Maybe.
Wait, why do we need to find the difference?
Because these are paired data, what we look at is it's better to make individual comparisons when you can than to make whole group comparisons. Okay, so as I look at this, because I'm allowed to directly compare those two numbers, that's what I'm going to do. Okay? All right. I think this one's pretty ambiguous to try to make a decision from just looking at it. What would we be looking for if the ice bath made a difference? Every number would be positive. We got more positives than negatives, right? Got a couple of zeros, one negative. To me, it's really ambiguous right now. Okay? All right. Now, when we have paired data, what we're going to do for our null hypothesis is not going to be comparing two means. We're going to be what we're going to do is talk about the mean of this column, which we're going to call mu d. So, the way we did these differences, what can we say if you guys just said this? The cooling resulted in faster time would be that mu d is greater than 0. You told me it would be positive because we did the no cooling minus cooling. And if we had subtracted these in the backwards order, that would just be a less than 0. Okay? Making my my null hypothesis less than or equal to 0.
Wait, why should it be positive? I just don't understand.
Because the standard time minus the cooling time, if the cooling time was faster, the cooling time would be smaller than the standard time, yes?
Okay. Yeah. Oh, okay. I didn't read the original question.
Everybody good?
Yeah.
Okay. You guys. And then,
Drinking a slushy.
huh?
I'm just reading.
Thing.
Drinking a slushy, how's that? It's gonna affect your time, I guess.
I'm on a slushie.
How's that
I could do like a cherry lime slushie right now.
gonna? Not cherry lime.
Definitely cherry lime.
Unanimous now.
She probably likes the Pepsi ones from Sheets. I can see you liking the Pepsi ones. Even though Coke is far superior. That's okay. Do you like she likes the Mountain Dew slushies.
Nope.
Oh, not those. Not those. Never mind.
All right, guys. To do this one, we are going to pick just the t-test in our calculator, just like we were doing when it was one sample. Okay? When it was one sample, we had a mean compared to a number, yes? That's what we have here too,
Yes.
okay? All right. And let's see, when we go to do that, you're going to go to stat, you're going to go to test, you're going to choose that t-test, right? We're going to do it from our raw data. The mean from our null hypothesis is 0, which list of data are we doing this on? L3, because the differences are in L3. So you just hit second 3. And then I better go down to greater than. You guys with me on this? Which is why you would definitely use the calculator to calculate those differences to begin with. Because you're going to have to, otherwise you got to type them into L3 anyway. It's way less work. All right, and we've got T equals 1.97. Wait, 1.987.
And P is 0.47.
P-value 0.4. What did you get, Nat?
1.145.
Oh, shoot.
Why is it positive? Oh, never mind. Just
Did you figure it out? It's just about to come back there. Okay, I'm gonna ask you the same question. Did the cooling work?
No.
Will it automatically change my number over? Around, like, since I changed, I put 22 point, I put like 22.5, but it was 22.6 or something. Will it change row 3?
I don't think so.
No.
I wouldn't think that it would.
Well, you disprove the null.
So how do I? So I'd go to,
Just go overwrite that number.
what?
Here, I have my differences listed here. Just go overwrite that. For the test, you guys, anything where you're putting the raw data in, I tell you what your mean should be so that you can know if you type something in wrong or not. All right, you guys. According to our p-value, our p-value is less than 5%, yes? So we are going to reject the null. All right. Which hypothesis goes with our claim here? The alternative. Are we concluding the alternative? Yeah. So do we have enough evidence to conclude the claim? To support the claim? Yes. Last one. What kind of data is this? Paired? Yeah? Okay. You guys, are we gonna do pre-test minus post-test or post-test minus pre-test? Doesn't matter, we just need to make a decision.
Post minus pre.
You wanna do post minus pre? Cause you don't like negative numbers, I'm assuming. And, ooh, this time we're doing a confidence interval, yeah?
Yeah. Yay.
There's no hypotheses when we do a confidence interval. Mm-hmm. Well, and if you're doing a 95% confidence interval, I'm telling you what the percentage is.
So we'd be doing a T interval?
Yep.
Is the frequency 0?
The frequency should be it should be completely blank.
Just like,
Yeah.
Saying error.
Yeah, I don't know. T.
T interval.
Okay, got it.
I have my frequency as 1. 'Cause that's what.
Yeah, that's what I got.
Not.
I don't know if that was standard.
If you didn't get this, but you got the exact opposite, like negative 3.68 to negative 2.58, that's fine. But then somehow you want to communicate pre minus post. Like I'm smart enough to, as long as you communicate to me somehow the order of your differences, it's fine.
Gotcha.
You guys, if we interpret this, we're going to say with 95% confidence, we can say the difference, and this is where this would get communicated anyway, Beck. So for instance, I'm going to say the difference between
And then
post and pre-test scores, whereas you would write pre-test and post-test scores,
sorry, if you enter, did you enter?
Yeah.
And then
right? Like that,
I got you. Yeah.
but it communicates the same thing.
Cool. Got it.
did you do maybe L1 minus L2? It has to be L2 minus L1.
Oh, okay.
Yeah, but you have that right.
And again, this is that would be the mean difference between the two groups. And there was nothing that said we had to do post minus pre. We could have done pre minus post. If that's the case, you ended up with a negative interval. Both communicate that there is a difference. Right? So if you had it in the other direction and then you had the negative interval, you didn't do anything wrong. It's just that you did pre-test minus post-test, and when you do that, you just got to make sure you're communicating which order you did that difference in some way. Okay?
Mm-hmm.
Hey, you guys.
But where are you getting the, like, these values? Are these from, like, the t-test?
Yeah. And your mean would have been negative 3.133. Standard deviation would have been the same.
Okay.
Everybody good? Sweet. So, did my students make progress? Because I'm going to say it a little bit differently. The entire interval is positive. Some of you might be saying because the entire interval is negative, and that's fine. Again, fine. But that suggests post is the mean of the post-test scores is higher than the mean of the pre-test scores.